It's March 11, 2016. Just a quick update here on the course conditions. Course fared pretty well this winter. You can see what we call pink snow mold. You know, very imaginative name, right? It's pink, but it happens during the winter, snow, and this type of fungus, mold. So, at any rate, that's a persistent issue during cool, wet periods. You can see there's some scattered throughout. We did treat it preventatively, but you get some breakthrough when the pressure's high. But what I want to point out here are these elms, elm and oak, and the shadow that it casts here in the late fall especially, and you can see how the poania here suffers much greater than the poania and the bent over there. You know, the plant relies on stored carbohydrates to get it through the winter and maintain its hardiness. So what happens is the shade, even though it's not really prevalent in the summer and late fall, through the late fall, about its impact to the plant, but at the end of the day, that plant's not getting as much quality light as, say, plants that are in full sun, and their stored carbohydrates are compromised, and the plant goes into winter much like you could say maybe a skinny bear does when it goes into hibernation. It's going to be more prone to issues. So we're coming up on the green. That same principle obviously, you know, applies on greens, tees, fairways, anywhere grass is growing. You got to have full sun, especially bent grass, and that's been part what's driving some of the tree reduction and heavy tree trimming. But we have we uncovered the greens. We opened them up for play. We haven't had a lot of play yet, but maybe 20 people I've seen, and but greens are doing okay. Number 4 here, number 10, 15 tends to be the worst, where you can see the poania is a little thin, off color. You can see a little bit of snow mold. You can see the fertilizer we put down. You can also see the air fire holes. So what we already got done within a week's time is remove the covers and verted drained them, deep tined them. We might run over the putting green. I'll show you Felix finishing that up. That's the last green. It took us 3 days. So we got nice deep tines, nice deep holes. We sprayed them for this pink snow mold. We fertilized them with an organic fertilizer and a biostimulant, and now it's supposed to rain over the weekend, and that should melt this in pretty nicely, and then we just got to play it by ear. I'm anxious to get sand on them, roll them, and then mow them once I think the weather is turned and not get heavy frost. We had a light frost this morning. If the weather turns backwards in the sense of temperature for any kind of extended period, I'll put the covers back on 4, 10, and 15 just to protect these areas that are a little thin and weak. So that's the update. It's welcome to spring. March 11, 2016, and heavy air here. Felix is on to something else, but heavy air is finishing up the what we call verted draining or deep tine, solid tine aerification. And it's pretty early to do this, but we found earlier the better, and then we'll try to get another treatment in a little later in spring, depending on the golf season and when we can pick away at it. We actually like doing this if we can, ideally like once a month, but realistically we end up doing this treatment about 4, maybe 5 times a year. When we can't get a big machine like this on the greens for whatever reason, usually it's the golf schedule that prevents it, then we go to a small needle tine that takes us only a day to get done if we have access, typically obviously on a Monday if we don't have an outing. And so I'm going to walk up here. You're not going to be able to hear me, but what I want you to see is how the ground reacts to this. We're not simply just poking a 9 to 10 inch deep hole. The ground around this tine is actually shifting slightly, so they call it shatter tine. So that shifting around actually fractures the soil, making it more pliable and easier for the roots to expand as they grow in this spring. So we're going to walk up there. Hopefully you'll see what I mean. the ground dancing. If you were here, you could actually feel it through your feet, how the ground shifts around. You could also see the slight lifting. We're really pushing it where we had a little lifting over on 18 and 17 where the ground actually heaved up. We had to just repair it. It's not a big deal, but you obviously don't want that to happen if you can help it. And as long as we don't drive over this, the surface is actually pretty smooth because of the rear roller that we mounted these shocks with the coilover spring on to allow for a firmer, more aggressive push. There you can see it lifted a plug out from changing the cups. Here, let's look at that for a minute too. It's amazing how quick the roots do start growing. Here's a white root come spring. Obviously, as the soil temperature is warm, the roots will grow even that much more. But this poania is really early to break dormancy and start growing much quicker than bent grass. That's one of the things about bent grass is it's slower in the spring to get going than poania, but that's also why you have some potential winter hardiness issues, because the poania can break dormancy, take in the free water. The bent grass does not do that, and if you get a sharp freeze at night, that free water can create ice crystals which puncture the cells, killing them. So that's so on one hand it's kind of a nice thing. So when you have early golfers, like we got a few guys out going out now, poania is actually pretty nice because it's already active. The bent not so much, but if you get winter kill, obviously it's not a good thing. So it's always trade-offs. It's March 11, 2016. We're here at North Shore Country Club, and it's a good time to see the impacts of biochar, a new selective herbicide that we've been involved with at an experimental level. It's due for EPA approval in a year or two, and it's something the industry has been looking for many, many years. Poania is a maverick weed. It's a very weak plant as an individual, but its strength is in producing copious amounts of seed every spring. Those seeds deposit. They stay dormant in the soil for years and years and years, and when an opportunity exists, which is either thinning of turf because of wear or disease, ball marks, vandalism, anything that keeps the turf vigor down, that seed is ready to grow and reestablish it. The weird thing about poania, though, it's a complicated plant. The genetics is great, greatly varied. And there's biotypes, they call them, different genetic individuals that really persist well and act more like a perennial, don't produce as much seed, and can tolerate the extreme heat and cold better than the other biotypes that tend to give off a lot of seed and want to die. It's heavily disease prone, shallow rooted, so it needs more water, especially surface applied water. And bent grass is the more hardy, tolerable species, more sustainable. So here you can see the different patches of grasses. These are the bents mixed in with the POA. There's different rates. Up here we have another set of blocks. You can see, right, I'll use my shadow. This is the square of bent grass. This is mostly poania here, probably 85% poania. And then you can see in this block with a different rate of biochar, it took back the poania, not entirely, but it set it back enough for the bent to encroach somewhat. You can see at this rate, there's more creeping bent grass, far less poania, and so on. Here is our NTEP trial, our most recent one, a couple years old now, and these have cultivars, 3 reps each of new bent grasses that some of them aren't even named yet. And what's fun about this plot, this is our 3rd set of NTEP trials. There's one here, one up there at that small chipping green, and one that's 20 years old now, and over there at our short game area. But this one here, what we did that's different is we killed the existing POA bent with Roundup and then interseeded the bent grass varieties in the dead thatch, knowing that there's that seed bank I just described laying there of the poania ready to grow with the bent. So with methyl bromide being removed from the market, the EPA banned its use, and that was our sole fumigant that you could use as a pre-plant to kill off that seed bank and plant into an existing green if you wanted to convert it to bent. That option is no longer available. So this would be another option that one might consider, which is to plant into the dead thatch like we did, knowing that the POA will come up with the bent, as you can see here, those light green patches here. This is the poania among the darker green. We'll get a closer look. This is the poania, and this is the bent grass. So what we did here is you can see the poania is almost in lines. Here I'm staying in the middle of this line, a lot of poania, very little poania. Lots of poania, very little poania. What we did with the University of Illinois is we did a strip test. We treated these strips with the biochar. And you can see how successful it was with one season, 2 fall apps, how well it knocked back that poania. If you follow up this season with additional applications, you would get this probably pretty doggone close to 100% pure bent. So basically what you do is you grow in your new bent side by side with the poania for a year, get that bent grass established, treat it with a biochar program, assuming EPA approves it, and now you're back in business again, never taking the green, out of play during that process, and really not really affecting play either. So it happens pretty seamlessly. Very exciting. You can see it hopefully on this video with this light. It's a little glary out with this heavy dew and the sun's pretty bright, but again, here is one cultivar where my finger is here. There's a white dot. Hopefully you can see another one, then another one here, and then there. So that's one variety split in half. The left side's got the POA that did not get treated with the biochar. The right side's clean, that was treated with biochar. The other thing that we're getting information on doing this study is the tolerance of all these cultivars to biochar. And under the program, they're suggesting the recommendation of the rate and the frequency. We have yet to see a strain of bent grass that does not like the biochar. It seems like they all tolerate it fine. So that's another piece of information we're gathering with these new varieties. We did that same study on that variety trial that's like 7 years old now, or 8, and then that one there that's 20 years old, we did the same thing. So we can say with certainty that biochar, the tolerance of biochar is high with these bent grasses as long as you follow the recommended rates. Now speaking of rates, this video is getting long, but that's what this trial was all about. And you can see varying degrees of poania sprinkled in with this bent. So this is one long block of various treatments. So here you can see right in front of me, hopefully, that's a pretty clean square of creeping bent. Mind you, all of this entire area looked just like that, just 85% or more poania. So you can see this block now is like 85% or more bent. You can see this block has a little more poania. Well, that was a lighter rate. This was a rate trial with it was the same rate. I misspoke. It's really the same rate, but the number of applications and the time of those applications. The fall applications tend to be more aggressive than spring. So a full-blown aggressive program could be, for example, 2 fall apps and 3 spring apps. If you were to do that, you can expect a block that looks like this, where it's mostly bent. If you did just 1 spring app, you would see you'd see this type of outcome, that the poania still is existing, but at a lower percent. You compare those with this block, that's our control, receiving no biochar, and you can see the gross difference. So it's just fascinating to see how this all works, because the industry's been starving for trying to control poania. It's 3/14/2016. Quick update on some of our greenhouse work here. We brought some plugs in from the golf course. A couple greens got a little hurt in some small areas, the number 4, 10, and 15. You can see this plug that we brought in from 4 bounced back really well. This one here is a little slower. I feel pretty confident. You can see the few little blades of bent grass among all this poania that's very stressed, weak, where the bent grass is doing fine. This plug is mainly all poania that came back. So some spots will take a little time. JD's going to go out and fertilize them again today. All organic fertilizer. It's supposed to rain hard later, so should water that in pretty well and kind of give us a more sustained approach to getting those to heal up, and then we'll babysit them with spoon feeding light rates of soluble fertilizer as spring continues to unfold. But here I want to go over this real quick. This set of blocks is a research effort that's very unique in that we have the same rootzone mix with biochar and all the biology that's out there, including vermicompost extract, strains of Bacillus, Pseudomonas, Trichoderma, mycorrhizae, these organisms that are known to be beneficial. And then what we have is 7 different cultivars of creeping bentgrass, one being Pencross, an old-time standard, another one Pure Distinction that is pretty disease prone, otherwise a good grass. The other ones are things like 007, Mackenzie, Luminary, V8. And what we want to see over time is if these grasses respond favorably and differently from each other, because plants do manipulate the environment through exudates that it offers through the rhizosphere, and develops relationships with these microbes that helps them get through stress times, disease suppression, droughts better than others. So this is still in its infancy. This one here is very exciting. This was the first block we set up. We have not watered this since 3/2, so that's what, 12 days now with no water whatsoever. And we're going to continue to keep these going without water. And the concept here is to see which soil amendment offers the best capacity for plant health, stress reduction, and drought tolerance. So here's our 8515 sphagnum peat, industry standard. You can kind of see thin, slightly off color. All these were managed the same, by the way, same fertility. You know, it's a scientific approach here. 3 reps of each. So here's 1, 2, 3 reps of the sphagnum peat, compared to, say, like here's 5% the Miramichi, which is a combo product of biochar, composted swine manure. This one here looks really good. This is 5% biochar, 5% biosolids. This one here is off the charts. You can see just how green and long and lush this is, and that's 5% biochar, 10% biosolids. So we have varying degrees of biochar and organic amendments compared to the industry standard. You can see just about all of them perform better than the peat, with the exception of this one is not doing too well in this one. This is the biochar alone, 10%. This is 5% biochar, 10% vermicompost. It actually is pretty good, but not as good as some of these others. So we're rating these, we're documenting with photographs, and this setup is similar to what's going on at Purdue with Cale Bigelow and Kevin doing research efforts with us, as well as the USDA down in Peoria. This one here is just kind of getting going as well. This is different. This is the same sand with the same biochar, but with different products that have different microbes, and the same grass. So we're trying to study and understand the value of having some of these inoculums, probiotics we'll call them, and see how it affects plant health, and eventually we'll do a similar thing as we did with that and put it under moisture stress. These rhizotrons are very interesting. You can see on the left the grass isn't quite as lush and full. This side here is the peat. This side here is the biochar vermicompost. You can see the amount of rooting that's taking place with the peat down to about here, with some fine roots, not a whole lot, compared to this side. It's got a lot more rooting structure, and it goes all the way down. Well, I can see some in here, but really the majority of them stops here. So I hope you can see that. You can see the top growth's obvious, but we're really most interested in what goes on underground. So these are old windshield frames from golf carts that have cracked, so we kind of just cannibalized a couple of them and made these rhizotrons. You got drain outlets, pea gravel, 12 inches of root zone, so that's supposed to simulate a USGA root zone, so we could see what's going on underground. Same thing on this one. You can see probably even better. Again, this is the peat 8515 industry standard. This is the 5% biochar, 10% vermicompost. You can see slightly darker in color because of the organic material, but again, few roots straggling down to about here. Here, I'm going to say 3 times as more roots, and they're all the way down to here. So deeper. I'm going to try to angle this so it's not so glary, I hope, so you can see. So the again, this material offers the plant better reasons to go down deeper and more established, so it can tolerate stress, dry out better, so we can firm greens up that much safer without compromising plant health.